Once the system is optimized for the 1 in 30-year events, it is sometimes required to undertake an assessment of a really large storm, such as a 1 in 100-year winter storm. During these types of rare storms, it is acceptable for flooding to take place, so long as that flooding is managed and does not cause damage to property or risk to people. Infodrainage includes the ability to route floodwater across the catchment surface. The direction and speed of floodwater is determined by the surface data. In addition to simulating a very large storm, you can artificially induce flooding by reducing the size of one of the upstream pipes. But before you do, best practice is to copy a design phase so that you can perform the exceedance calculations without altering the data you have so far. In the tree view, right-click the phase Optimized SUDS Design and select Duplicate. Name the new phase Exceedance Assessment. Then exclude the Optimized SUDS Design phase from analysis and turn off its visibility. Next, in the model, select pipe 1.003 and then change its size to be just 3 mm in diameter. Then, save and validate the model. Be aware that in InfoDrainage, 2D assessments are conducted for one storm at a time, as the concept of critical duration does not really apply to flooding across a catchment surface. Therefore, the first task is to determine which storm or storms should be used in the 2D analysis. On the ribbon, Rainfall Pollutants tab, Rainfall Panel, click Rainfall Manager. In the Rainfall Manager, duplicate the SPR Wizard FSR Storm and call the new study Exceedance Storms. Set the return period to 100 years and the increase rainfall value to 40%. Save the rainfall event and name it 100-year plus 40. Next, on the ribbon, Analysis tab, Criteria panel, click Analysis Criteria. In the Analysis Criteria dialog, under Select Rainfall, change the rainfall to the Exceedance Storms event by enabling its checkbox and disabling any others. There should still be 18 storms. Click OK. Next, validate and then run the model. Click the Analysis tab on the ribbon again, and then click Validate. In the Validate dialog, no errors appear, so save the file. Now you can run the model. On the ribbon, click Go. Once it has finished the calculations, click Critical Storm. The results show that only the cellular storage floods. The critical duration event for it was the 360-minute winter event. You will therefore carry this event forward to 2D analysis. In reality, you may want to look at which junctions flood and possibly run a series of simulations. On the ribbon, click the 1D 2D analysis button. In the 2D analysis criteria dialog, keep the urban setting for Manning's equation. Enter 10 meters squared for the minimum element area. This determines how small the mesh is, which is formed from triangles, and therefore how detailed the analysis is. It also greatly affects the speed of the analysis. Finally, select the Exceedance Storms rainfall and the 100-year plus 40%, 360 minutes winter storm to run. Click OK. After the calculations are complete, look at the Stormwater Control Summary. Here, you can see that the results have changed a little in comparison with the 1D simulation. In the Tree View, for the 2D analysis, switch on only the Depth and Legend options. From the bottom left corner of the screen, run a replay to see flooding across the catchment surface, or stop the replay to see the worst-case scenario. Right-click the 2D analysis and select Display Settings. Here, the color ramp dictates the colors of the depth that can be rendered after a deluge analysis is run on the surface. In the dialog, enable the depth layer to turn it on, but leave contours and flow direction off. Set the edit maximum value to 0.5 and the edit minimum value to 0.1. Expand the ramp dropdown to choose a color scheme. Notice how the surface appears with the Show Continuous Surface option on. When Show Continuous Surface is selected, the grid elevation is applied at the center of each grid square and the elevation linearly interpolated in between, which makes it appear fuzzy. The deluge water surface can also be drawn as a series of independent grid elevations. Turn Show Continuous Surface off. Now the deluge appears clearly as triangles.